Good evening. So for today, I will be discussing about chapter 4, which discusses and encompasses electricity, magnetism, and electromagnetism. So this chapter includes the basic concepts of these three and how significant it is in modern X-ray imaging systems. So, the primary function of the X-ray imaging system is to convert heat energy into electromagnetic energy, or now known as X-rays. Yes, so the study of electricity, magnetism, and electromagnetism is particularly important. Yes, so this chapter begins by introducing some examples of familiar devices that convert electricity into other forms of energy. So yes, when we talk about this, an example of that would be the X-ray tube, which is where X-rays are being made, and these are made by heating the X-ray tube, and then it releases electrons in the form of mostly heat energy, 99% of that, and 1% of them becoming X-rays. So electrons are being transferred from the X-ray tube from anode to cathode, and from cathode to anode, and when it hits the anode, which is usually a tungsten target, X-rays are being produced. Yes. So, so electrostatics is also being discussed in this chapter, which is the science of electric charges that are stationary or not moving. Electrodynamics is the science of electric charges in motion. And electromagnetism is the study of electric charges when they are given electric potential or voltage. Yes, so this chapter also discusses about magnetism, which has become increasingly important because of its significance in the field of magnetic resonance imaging, which is one of the medical procedures in diagnostic imaging. Yes, so it also discusses about how magnetism behaves, and I also forgot to mention that magnetism is also the study of electrons in motion, which creates magnetism. Yes. Chapter 4 also discusses about electromagnetic induction, which is the transfer of electric potential from one position to another position. Yes. So how do we know that an object is said to be electrified? So by definition, an object is said to be electrified when it either has too many or too few electrons. Electrification can be processed through friction, contact, or induction, which is the transfer of electric potential, also known as voltage. Yes, so there are four general laws that describe how electric charges interact with each other and with neutral objects. So, first one I would like to discuss about is that alike charges repel one another and unlike charges attract one another. So this is because when there are like charges that approach each other, they repel each other because their electric field are both facing the opposite direction, which causes them to repel from one another. While if they are unlike charges, positive to negative and vice versa, they attract each other because their electric fields are not going towards the opposite, but they are going towards each other, which causes them to interact and be attracted to one another. I would also like to add that the force of repulsion between like charges or the attraction between unlike charges are both attributable to its electric field. So the attraction is between two charges is also with respect to the inverse square law, where the greater the distance of one charge with another, the lesser attraction would be if there is a greater distance. But if the distance closest between two unlike charges, the force of attraction also greatly increases. Now, I would like to talk about the magnetic laws. So, the physical laws of magnetism are very much similar to that of the electrostatics and gravity. Yes. So, contrary to electric charges, however, magnetism does not have a smallest unit. So if we break down a magnet, it will only create two smaller magnets, and if we break that smaller magnet down, it will still be just another two smaller versions of the magnet. Yes, so there are four magnetic states of matter. We have the non-magnetic, diamagnetic, paramagnetic, and the ferromagnetic. So non-magnetic are states of magnetic matter that do not get magnetized or do not get affected by magnets at all. Um, Diamagnetic are states of matter that are weakly repelled from both poles of a magnetic field, so they are weakly repelled. Paramagnetic are weakly attracted to the both poles of the magnetic field, and the last one, ferromagnetic, are magnetic states of matter that can be strongly magnetized.